Hello human body system students. Today we're going to be doing the top half of the antidiuretic hormone feedback loop mechanism for the maintenance of blood water concentration. So this is for section 3.4.4 and we'll just title it as ADH feedback loop. So for your assignment, we're going to do the top half of the feedback loop together, and then you're going to do the bottom half on your own. So remember, our feedback loops always start with homeostasis in the center. So this is whatever your body wants to maintain its blood water balance at. And then we're going to have an upward arc, which we'll do together, and a downward arc, which you'll do on your own. So the stimulus that the body feels for this upward arc, we're going to be going with not enough water in the blood and then returning to normal. So that's the swing of the figure 8 arc that we're going to do. So the part of the body that detects low water concentration in the blood are called osmoreceptors, and those are found in the hypothalamus of the brain in great concentration. So we'll just say detected by osmoregulators in hypothalamus. So the hypothalamus is monitoring your blood to see how much water is in it. If the osmoregulators in the hypothalamus detect that there's not enough water, then the hypothalamus is going to signal to, remember from when we did the endocrine system, that the hypothalamus is basically like keeping track of everything, and then when something needs to happen, it tells the pituitary gland what to do about it. So the hormone secreted by the pituitary gland when there is not enough water in the blood is ADH, antidiuretic hormone. So antidiuretic hormone has a couple of different functions in the body to maintain blood water concentration, but the one that we are most concerned about in this unit, where we're studying the renal system, the urinary system, is the effect that ADH has on the kidney. So when you have increased ADH concentration in the blood, this increases permeability of the collecting ducts in the nephron, to water, meaning essentially that as urine is produced, it travels through the system of tubules in the nephron, which you'll have reviewed in the video that you watched before this. And as the liquid urine passes through the collecting ducts, water is reabsorbed. And if you have more ADH in the body than normal, then that's going to stimulate the collecting ducts to reabsorb even more water. So that'll be our next point on here. More water is reabsorbed from the urine. When more water is reabsorbed from the urine, you have more concentrated urine produced. So there's a higher percentage of solute to water in the urine. And then we'll say blood water volume increases. And this, of course, the last loop of our feedback, water returns to normal, and now we have come back to homeostasis through this process. So again, not enough water in the blood, detected by osmoregulators in the hypothalamus. The hypothalamus tells the pituitary gland to pump out ADH. As ADH travels to the kidneys, the collecting ducts are stimulated to absorb more water out of the urine, so you've got water reabsorption. This causes your urine to be more concentrated. As more water is reabsorbed, the blood water volume increases and returns to normal. So now what your assignment is to do the high water feedback loop. So we did the low water when there's not enough, and so now you on your own are going to do the high water when there's too much water in the blood, and you're going to follow this same process, except it's going to be kind of the reverse. So just pay attention to the role of the hypothalamus, the pituitary, and ADH in the blood reabsorption of water in the nephron.